Hello everybody, and welcome to the continuation of page 21 in the workbook. And we're going to be talking about the second of the two vector operations in this section. This one's called the cross product. We already defined the dot product above. Okay, and cross product of two vectors is defined as follows. So we're going to start with the same kind of two general vectors in three-dimensional space that we did before. The cross product is going to be noted by this notation, Vxw. V cross W is the way we read that. And here's the formula for the cross product. Okay, notice it's a kind of a big long formula, and it's very different from the dot product in the sense that what we get is a vector and not a scalar. This is a vector quantity. It has an I, j, and a k in the formula. So that's a big difference between a cross product and a dot product. Okay, well, you look at this formula, and this would be a difficult formula to memorize. There are a lot of symbols in it. It's very long. And so what I'd like to give you is a way to calculate a cross product that will allow you to kind of come up with this formula without having to memorize it every time. Okay, the one catch here is that we need to use something called a determinant to do this. And some of you may have calculated determinants before. If that's the case, this process might be familiar to you. Otherwise, this may seem strange to you the first time that you see this. Calculating a determinant is kind of an unusual definition. Okay, so keep in mind that you can watch this video a few times if you don't catch it the first time, and you're always welcome to come to my Zoom office hour and ask me to explain something slowly and in more detail. That's something you might want to do with this example, and something you can do, by the way, with anything over the course of the semester. I'm always happy to do that. Okay, so that said, how do we actually calculate this V cross W? Okay, well, I use the word determinant. Here's what a determinant looks like. Okay, we're going to make an array of numbers, and in the first row is going to go I, j, and k. And then the second and the third row are going to contain the components of our vectors v and w in that order. Okay, so second row is going to have v1, v2, and v3 in it. Third row, w1, w2, and w3. Okay, this is called a determinant, as we mentioned. Okay, how do we do a determinant? Okay, well, the first thing is we attach signs to the I, j, and the k. There's going to be a plus sign that goes with the I, a minus sign that goes with the j, and a plus sign that goes with the k. That's just the way that a determinant works. Every time you do one, that's going to be your very first step, to attach those signs. Okay, now let's talk about the actual calculation of this. Okay, the determinant is going to consist of three pieces to it, one by one. And to get the first of the three pieces, here's what we're going to do. We're going to find the I, and we're going to cross out the row and the column that I occurs in. Okay, and what that leaves is kind of a 2-by-2 array of numbers, and here's what we're going to do with that. Okay, we're going to take the upper left and multiply it by the lower right. That's going to give us V2W3. And then we're going to subtract the upper right times the lower left, V3W2, and we're going to attach an I to that. And the last thing we're going to do is notice that plus was the sign that went with the I, so there's going to be a plus that goes in front of there. Okay, that's the end of the first of the three terms. Okay, and now we're going to repeat that process with j and k, and just so that our diagram doesn't get too cluttered here, I'm going to erase what we wrote before and just rewrite it, okay, because we're going to be crossing out rows and columns again. Okay, so this is just recopying what we had at the beginning. All right, and now we're going to move on to the j, and we're going to cross out the row and the column that the j lived in. Okay, so we'll start by noticing the sign that goes with the j. It's a minus, so we'll put a minus. Okay, and then what we're going to do is take upper left times lower right again, so V1 times W3 minus upper right times lower left, which is V3W1. Okay, and then that's going to get multiplied by J. All right, and so that's the end then of the second of the three terms here. All right, and again, let's erase what we had before. Start fresh. Okay, so we had an I, J, and a K, a V1, V2, and a V3, W1, W2, and a W3. And now we're going to cross out the row and the column that the K is in. Okay, and repeat the process. So this time we've got a plus sign associated with that, so we'll start with that. And then, let's see, upper left times lower right is V1 times W2 minus upper right times lower left is V2W1. Okay, and that's going to get multiplied by K. All right, my question to you is, does that formula match the formula that we have up here? And you might be concerned about what you're seeing in the middle. Okay, those terms don't seem to match at first, but notice that there's a difference between the signs. And if we do one more step here, okay, I'm just going to rewrite the first part of this. We can take this minus sign and distribute it through, and notice that if we do that, we're going to get a minus a negative for those two terms, V3W1 minus V1W3. By doing that, the formulas do match each other. Okay, so if you compare this formula and this formula, they are exactly the same now. Okay, you can look through all of those terms and just confirm for yourself that we got the same thing. Okay, so this determinant method, if you follow this process, it will naturally lead you to this cross product formula. Okay, now the question is, what information is this formula really giving us? What is it telling us? Okay, let's do a specific example to kind of answer that question. This is on the next page. Okay, so here they're giving us two specific vectors, u and v, and they'd like us to calculate two cross products, u cross v and v cross u, and we'll draw pictures of those and see if we can kind of tease out some geometric meaning here. Now let's start with u cross v. Okay, so if we do that calculation, we're going to be doing a determinant, I, J, K. Okay, and the first thing we'll write is the components of u, so 1i plus 2j, and there's no k, so the k component is 0, and then v, negative I plus 2j plus 1k. We need to calculate that determinant, and remember the signs again, plus minus plus. Okay, and we'll follow this process, maybe a little bit more quickly than we did on the previous page. All right, so the first thing we do is to cross out the row and the column that the I is in. We're going to get a plus 2 times 1 minus 0 times 2, I. Okay, and then we move on to a minus for the j component, and if you cross out the row and the column that the j is in, we're going to get 1 times 1, upper left times lower right minus 0 times negative 1. Okay, I'm running out of space here, so let me move to the next line. And then k, if we cross out the row and the column there, we're going to get, of the k, we're going to get 1 times 2 minus 2 times negative 1. Okay, all of that's going to be times k. All right, and if we simplify all of that down, let's see, 2 times 1 minus 0 times 2, that's just a 2i. Minus, okay, 1 times 1 minus 0 times negative 1, that's just going to be a plus j. Or, whoops, sorry, I forgot the minus sign. There's a minus in front of that. Okay, so that's actually going to be a minus j. Okay, and then the last piece here, 1 times 2 minus 2 times negative 1, what's that going to give us? 2 plus 2 is 4, it looks like, plus 4k. Okay, there's u cross v. Okay, where would that appear in our diagram? Okay, well, notice that there's a point in our diagram labeled 2, -1, 4, and so the vector 2i minus j plus 4k is going to start at the origin. It's just going to go to that point. So u cross v is actually going to be right there. And notice that that vector has a very interesting property. It's actually perpendicular to both u and v at the same time. That's kind of the key property of the cross product. Okay, let's do the other cross product, v cross u. Okay, that's also a determinant. Okay, space is a little bit tight here. In this case, we're doing v first, so we want to write the components of the vector v first. So -1, 2, 1. Okay, and then the components of u, 1, 2, 0 again. We're just going to repeat this cross product calculation again. Okay, so we'll cross out the row and the column that the I is in. Okay, and then we're going to get 2 times 0 minus 1 times 2. So 2 times 0 minus 1 times 2i with the plus sign. Then we move on to j. There's going to be a minus sign associated with that. And then let's see, that's going to be -1 times 0 minus 1 times 1. Okay, and then finally we move on to the k. That's going to give us a plus -1 times 2 minus 2 times 1. Okay, and if we just work those calculations out, let's see, 2 times 0 minus 1 times 2, that's going to give us a -2i minus, and then minus 1 times 0 minus 1 times 1, that's going to give us a -1. Okay, and then finally you can do the arithmetic on the last one and see that we're going to get a -4k, which if we simplify, looks like -2i plus j minus 4k. Okay, there's v cross u. And what's interesting about it is notice that it's the exact negative of what we got up here for u cross v. And so in our picture, what that means is that v cross u would just point the exact opposite direction. Okay, down there. And so notice that it also has the same property of being perpendicular to both u and v, just in the opposite direction. Okay, so u cross v and v cross u are always just going to be negatives of each other.